How about a round of applause for Paul? Does that picture remind you of anybody? And set me up. That's good. So tonight I'm going to be talking about the riddles of the Kemp's Ridley sea turtle. But before I get into that, has anyone been to one of my previous talks on the riddles of the Ridleys? So we have a couple? Okay, a few years ago. All right, all right. Well, as you know, the first part of my talk, I like to do a historical perspective about the species. So you that have seen it before, you can just take it easy, update your Facebook status or something like that. And then I give a little update towards the end of that about the status of the Kemp's Ridley sea turtles. And then the second part of my talk, I talk about the research that we're actually doing here at the Conservancy. So the Kemp's Ridley sea turtle. Cute? Yeah. Cuddly? Not at all. Whenever we bring them in the boat and we catch them in the wild from the waters, they want to bite. And they have claws. Their back flippers have a claw that's like a velociraptor claw, and that cuts into flesh very easily. So they're a fighter, and they've fought for a long time, and as we'll see tonight, they've fought their way back from the brink of extinction. So, riddle of the Ridleys. I can't take credit for that statement. That was coined by Dr. Archie Carr with the University of Florida. Dr. Carr was one of the first recipients of a zoology doctorate from University of Florida in the 40s. And then he went on to become a professor at the university. And he's also known to some as the father of sea turtle research, at least in the United States. And so in a book that he wrote in 1956 called The Windward Road, he had an entire chapter that was dedicated, it was even entitled Riddle of the Ridleys. And what he did was lament about just how little bit we knew about this species of sea turtle. So I'm going to portray a little bit of that before we get into the details of research. So, back in the 40s and the 50s, sea turtles were still being harvested from our waters and eaten. People I've worked with, including turtle fishermen such as pictured here, tell me that turtle is so good if you put a piece of meat on top of your head, your tongue will slap your brains out trying to get at it. But I've never had the opportunity, nor would I likely. But anyway, so this is a former turtle fisherman, Junior McCain, out of the Cedar Keys. And when Dr. Carr was talking to the fishermen back in the 40s, early 50s, they all knew about this little turtle called the Ridley. It was called the Atlantic Ridley at that time. Its name has changed over the years, but that's another story. But they all knew about this little turtle called the Ridley. And they had some very colorful language about it as well. One fisherman in particular was quoted as saying, "He's a bastard. A crossbreed you get when a loggerhead mounts a green, and a loggerhead will mount anything down to a stick of wood when he's in season. This your Ridley don't have no young'uns, he's at the end of the line like a mule." So we can take this authentic Florida cracker gibberish and translate it a little bit. And what the fishermen were telling Dr. Carr was, the Ridley is a sterile hybrid, excuse me, of two other species, the loggerhead and the green. Dr. Carr was a little more worldly, and he knew there was another Ridley species, the olive Ridley, that was found circumtropical where the Kemp's Ridley does not occur, and they nested and they bred. So he knew there was another Ridley that bred, and it was likely the Kemp's Ridley bred as well. So he dismissed that first part that the fisherman told him. But the second part was the perplexing aspect of it, is that they'd never seen any mature turtles. They'd never seen a turtle with eggs, nor had they seen a Kemp's Ridley nesting. So they're all immature turtles that they were catching along the coast of Florida. So Carr spent the better part of 20 years trying to solve this riddle of the Ridley. Where are the adult turtles? Where do they nest at? And in 1965, one of his colleagues, Dr. Henry Hildebrand in Texas, discovered a film that was made in 1947 and sat in a desk of a person in Mexico for the better part of that 20 years while Dr. Carr was canvassing the Gulf Coast trying to find the Ridley nesting. And it was brought to his attention at a scientific meeting. And I would have loved to have been a fly on the wall because Dr. Carr was also a very colorful person. And I'm sure he had some choice things to say when he saw this film. So here is a clip of the actual film. And this is a Kemp's Ridley nesting during the day. Most turtles nest at night, but the Kemp's Ridley nests during the day. Not only that, they nest in these huge aggregations. The Mexicans referred to them as arribadas, or the arrival. And here you can see, panning down the beach, there's a person for reference. All the turtles along the beach, coming and going, throwing sand in the dune line. You could walk on turtle backs and not touch sand. There's so many turtles. So that riddle of the Ridley was solved. We knew where they nested. It was a very isolated rural stretch of beach along the Mexican Gulf Coast. And here's a map for reference. Here we are over here in Naples, Florida. And if you were to get in a boat and drive west-southwest, you would eventually run into Rancho Nuevo, Mexico, on the Gulf Coast of Mexico in the Mexican state of Tamaulipas. It's very, like I said, very isolated, very rural, so it was kept a secret, at least from people like Dr. Carr. He had actually driven up and down a coastal highway by Rancho Nuevo, and at one point saw shells from adult Ridleys in a cantina, but he never made it to the beach to see the nesting. So he just missed it. So now that we've established where the Ridleys nest, and you saw the huge nesting aggregation that came ashore in 1947, biologists started going to the beach after that film was discovered, and they found the nest numbers weren't as high as they were originally predicted. So here's a graph. Scientists like graphs, and you're going to see a few of those tonight. So on this axis, this is the number of nests, 10, 20, 30. I had to break the scale here and go to 90,000 because if we continued, it'd go through the roof, literally. And then on the x-axis here, we have years. So in 1947, when that film was shot, it was estimated that 40,000 turtles nested in a single day. And then if you extrapolate Ridley's nesting 2.5 times a year, I'm not sure how a turtle lays half a nest, but that's how the math works out. It was estimated in 1947 over 90,000 nests were laid by Kemp's Ridley turtles. Now by the time the film was discovered and we started patrolling the nesting beach, the numbers were down to a few several thousand. And over time these numbers kept declining and going down and going down. They reached a low point in 1984. There were 700 nests the entire year. Now, I've stopped at 1986 because that's when I started working with Kemp's Ridley sea turtles. And when I came on board, it looked like we were seeing a species headed for extinction. And they were given high priority as such. They're considered extremely or critically endangered, the most endangered sea turtle species in the world. So the first thing we wanted to do was identify the causes of that precipitous or rapid population decline. And it was kind of a 1-2 punch. The first punch was at the nesting beach. Humans were collecting the eggs. I'm told that the eggs, if you bake with them, they make one of the fluffiest and softest cakes you'll ever have. And there's also a legend that they can contribute to male fertility as well, although we have other medications for that these days. So the eggs were being collected from the nesting beach. Ridleys come ashore during the day in these huge arribadas, huge aggregations that makes them easy pickings for humans to run up and down the beach and collect the eggs. Now those turtles that were surviving the onslaught at the nesting beach and swimming out to sea were then accidentally being caught in shrimp trawls. I remember Forrest Gump, the movie Forrest Gump. When he came back from Vietnam, he started shrimp trawling. Well, actually, the shrimp fishery took off after World War II, when all the GIs came back from the Pacific and European theaters. So starting in the late 40s into the 50s, the shrimp fishery really took off in the States, and a lot of turtles were accidentally being caught. And so this is what contributed to that very rapid decline in nest numbers. So once the problem has been identified, we take corrective measures, and we began a binational conservation program. And it's binational because the Ridleys nest in Mexico, but the little turtles come to US waters to grow up to be adults and go back to Mexico. So doing protection in one or the other area wouldn't do any good. It has to be a collaborative effort between our two nations. So starting in 1978, they began a very intensive program of collecting the eggs from a given arrabada, nesting aggregation, and then taking them back to fenced-in corrals and reburying each clutch of eggs, each nest, in a little corralito, or a little corral, waiting for them to hatch, collecting the hatchlings, and then driving up and down the beach and seeding the beach with hatchlings and letting them go. So that took care of the heavy predation and human impacts on the nesting beach. And then starting in the late 80s, when I came on board, both US and Mexico started requiring the use of turtle excluder devices. So this is a shrimp trawl. It's like a big sock that's pulled through the water, and it collects anything in its path that can't swim out of the way. And what they did was they installed these devices halfway down the net, so you have the turtle coming in the trawl. It encounters, in this case, an iron grate, and it's deflected out a trap door while the shrimp pass through and are collected in the cod end of the net. It's called the TED, or the turtle excluder device. And both US and Mexico require their use in their respective federal waters. So here is the graph extended out. Remember, we stopped right here in '86, so now we've extended it out. Nesting beach protection started in earnest in '78, but the nest numbers kept going down. Turtle excluder devices came into being in the late '80s, early '90s. And a few years later, we started seeing upticks in the number of nests at Rancho Nuevo. I had the pleasure of spending a month there in 2000 when we had 600 turtles come ashore in one day. And 2 days later, we had 400 come ashore. And at the time, that was unheard of. And as the years have gone on, you see the numbers have climbed up. It's almost a exponential increase. And then in 2010, it dropped. A lot of people are quick to blame a certain event that happened in 2010, the Deepwater Horizon. However, the Kemp's Ridleys are off the nesting beach by May, and they're breeding. The Deepwater Horizon event was in April, so that didn't affect their migration to the nesting beach. There's some other factor that did, and the jury's still out on what that may have not have been. But then the nesting rebounded the following 2 years, and then it started going down again, and everybody was up in arms that maybe there's some unknown mortality factor that we haven't accounted for. Last week, I got updated data from 2015, so I've extended the graph again. And we look at here, 2015, 2017, we had the largest number of nests ever recorded at the beach since the 60s. So the numbers are fluctuating. If you were to kind of draw a line, maybe around 15,000 nests a year, some are higher, some are lower, but they look like they've leveled off. And it's not a bad number. It's still shy of what's needed to downlist them from endangered to threatened. We need 20,000 nests over a period of years for that to take place. But it certainly could happen in my lifetime. So that's great news. But 2018 was another down year. However, in one day in May of last year, May 26th, they had 8,000 to 10,000 Ridleys come ashore in a nesting event. And that was the largest single nesting aggregation they had seen since the history of the program there. So this is, it started off as kind of a sad story, but it has a happy ending. They're not out of the woods yet, but we have brought them back from the brink of extinction through our conservation efforts. So I like to give that little, I drop you down and then we bring you back up. So it's a nice little historical perspective. So I'm going to change gears a little bit now and talk about some of the research that I've been doing with Kemp's Ridley sea turtles. Here we have another cute and cuddly Ridley coming on board the boat. And I've been looking at their feeding habits, what they eat, the foods that they like to consume. And there's a quote from a book. It's one of my favorites. It's Carl Ernst and Jeff Lovitch in their book, Turtles of the United States and Canada, where they say the Kemp's Ridley is carnivorous, it's a meat eater, and eats almost any small living marine animal that crosses its path. So what they're saying is they're not picky eaters. They'll eat just about anything. But I think it's not so much that they're not picky eaters, is they're choosing what's available to them at a given time and place. And in this case, this is a picture of a Kemp's Ridley from the 10,000 Islands that's come to the surface. And this is what's left of a stone crab. Looks like he's already eaten the legs and the claws off of it, and this is the shell of the stone crab that's left here. And then the authors went on to say crabs, especially Calanectes sapidus, or the blue crab, in the common name, are its most eaten food item. And here's another picture. This was taken by a tourist from England who was walking up and down Naples beach with one of these big telephoto lenses that birders seem to love. And he saw something happen out in the water, and he just swung his camera around and fired off a quick burst. And this is the 1 in a million shot that he got from that burst. You see a Kemp's Ridley coming to the surface. Here's a blue crab that seems to be clinging tenaciously to its beak as it throws its head out of the water. So another fine example of the feeding habits of Kemp's Ridley. And if we look at a lot of the scientific work that's been done, it suggests that blue crabs are the most commonly eaten item. However, if we look at Western Florida, the work that colleagues and I have done in Western Florida, we get a little different picture. We've done a number of studies up and down the coast and quickly give some of the highlights of it. In Dead Man Bay, looking at turtle diet there, 100% of the samples had spider crab and only 20% had blue crab. At the Cedar Keys, where I cut my teeth on Ridley research, we found 42% of our samples had stone crab, 25% had blue crab. More recently in Charlotte Harbor, mostly spider, and now a new species, the purse crab. Blues were only like 5%. And then in the 10,000 Islands, 42% and 38%. So spider crabs, walking crabs, seem to be a more common food item in Western Florida, not so much the blue crab. And that may be related to the availability. Spider crabs may be more abundant than blue crabs. But there was something else about our study in the 10,000 Islands that caught our attention. 73% of our samples had tunicates. What's a tunicate, you say? This is a tunicate. It's a sea squirt. It's basically a leathery sac with a gelatinous interior, the organs of the animal. It's a filter feeder. It takes in the water and filters out the algae, expels the water out, hence the name sea squirt. You pick one up and squeeze it at somebody, it squirts water at them. And the Kemp's Ridleys in 10,000 Islands were eating tunicates or sea squirts. Never been observed in any of the studies decades prior. So we had another riddle on our hand. Not only were they eating tunicates, a novel food item, they were eating them like popcorn. This is a picture, this is one sample from a turtle. And when I say sample, I'm talking about poop samples. We collect poop to see what the turtles are eating. And it's a crappy job, but somebody's got to do it. And in this particular sample, there are 104 individual tunics, or outer coverings, of tunicates. Here we have some stone crab, and here we have some spider crab. So this is very interesting, and my boss and I at the time wrote a paper about this novel feeding behavior by Kemp's Ridley turtles. We called them carnivorous grazers, because tunicates are stuck on the bottom. They don't move anywhere. Once they settle out, that's where they stay. So the turtles are basically grazing on the bottom, eating these animals, carnivorous grazers. We went on to say that they're opportunistically feeding on more easily captured. It's easier to capture something sitting on the bottom than a crab that's crawling around, and possibly more abundant. So that kind of plays into that availability that Ernst and Lovitch were talking about earlier. So scientists like numbers, we like calculations, and I'm no exception. So those numbers I threw at you earlier were frequency of occurrence. So we have the number of samples that had a food item divided by the total number of samples times 100. So if I had 100 samples, 73 of those had tunicates, you get 73%. Pretty straightforward. Another metric we like to use is the weight of the sample, where we take the dry weight of the food item and divide it by the total weight of all the food items. But there's a problem with both of these. You can get a very frequent food item that doesn't weigh much, so you can get a sort of a biased picture with one metric versus the other, or you can get few items that weigh a lot. And so we've created yet another calculation using both of these metrics that we call the index of relative importance. So, and it just incorporates both of these proportions into calculating yet another proportion. So that's all good and well. Let's see some examples. So with our sandy skin tunicates, 73% of the samples contained tunicate. It accounted for 41% of the weight, so it gives us the magical number of 84% for that relative importance. Spider crabs and purse crabs were fairly frequent, but they didn't have much weight, so they have a lower index. Now let's skip forward 15 years to recent studies in 2014 and 2015, and we see something interesting happening here. Tunicates were in only 11% of the samples. They were less than 1% of the weight and negligible index of relative importance, as were the crabs. So what were the turtles eating, you might ask? Two entirely new food items. So these turtles never cease to amaze. Just when you think you got them figured out, they throw a curveball and eat something entirely different. They're eating a different tunicate. It's a colonial tunicate. It's an encrusting organism. It grows on the surface of other things, such as the drift algae that floats in and out with the tide. And then we also found them eating sponge. And these were whoops, jumped ahead of myself there. These were the most important items in their diet. So we've got another riddle here. Now, spongivory, as it's called, eating sponges, is not uncommon in sea turtles. It's just uncommon in the Ridleys. Nobody's ever documented Kemp's Ridleys eating sponges. There's another species called the hawksbill that inhabits coral reefs, and they feed on sponges, as do some of the other turtles to a lesser degree, but not the Kemp's Ridley. And we found, much like the tunicates, they were eating sponge in mass. Here's an aluminum weighing dish. This is some stone crab claw and fragments. This is all sponge that the turtle has eaten, tremendous amount. This is a small fragment that we used to identify, sent it off to an expert at Smithsonian who helped identify the species. Here's another species of sponge we found in these trays. Here's a little bit of spider crab and a little bit of purse crab. Very low weight contribution relative to the sponge. So why sponges? Why weren't they eating tunicates? The answer came in some anecdotal statements and photos that were being made at a website from Sanibel Island. It's called I Love Shelling, and it's basically a blog that a person writes as they walk up and down the beaches of Sanibel Island looking for shells. And they noted that during September through November of 2014, lots of tunicates were washing up. These are all sandy-skinned tunicates on the beach, lots of them. There's a person back there for reference. So it appears like there was a massive die-off of the tunicates, the Kemp's Ridley's food source 15 years ago. And so they switched to the next best available thing sitting on the bottom, which was the sponges and another tunicate. So it, again, ties into their opportunistically utilizing available food sources. Not only did we see that big 15-year change, we've seen a year-to-year and season-to-season change. In South Florida, we have two seasons. We have the wet season from June through November, and we have the dry season, December through May, which we're in right now. And we've noted a seasonal change in the diet of Kemp's Ridleys in the 10,000 islands. When we started in 2014, they were eating the sponge. The next late dry season, 2015, they were eating the encrusting tunicate and a different sponge. And then a year later, eating the white crust tunicate and crab species. And we've been doing this study every year, every season since then. In 2016, we saw a shift from the tunicate to eating more crabs. And then in 2017, in the late dry season, they were eating primarily crab species. And then something happened in the late wet season of 2017. Anybody? Armageddon. Irma roared ashore southwest Florida as a Category 3 storm, sustained winds of 115, gusts to 130, 140. And the star here, this is our study area. So our study area took the brunt of the storm. This is the right quadrant of the storm, which is the most powerful part of the storm, at least hurricanes in the northern hemisphere, that right quadrant. Actually, if the prediction had come true, Irma would have skirted the coast and that right quadrant would have gone right up the coastline, which would have been catastrophic. But at the last minute, it took a jog to the right and kept most of it, the worst part of the storm anyway, out to our east. However, our study site wasn't so lucky. There's lots of damage to the habitat. The grocery shelves were cleared out. The grocery store was damaged for the turtles. And they left. They took off. We didn't see them for a few months. And now they've slowly started coming back after Armageddon. And guess what they're eating now? Blue crabs, just like the authors said earlier. But what this shows us is usually diet studies are 1 or 2 years duration. And if you were to take any 1 or 2 years out of this more or less continuum, you might not get the true picture of the variability in their diet. So that is where the benefit of this program is leading us. We have one of the longest running diet studies of Kemp's Ridley turtles in the water. And now the question is, what does the future hold for them? Are they going to eat crabs? Are they going to eat something entirely different? We don't know. But time will tell. And we'll hopefully be continuing collecting our data. So I want to end with some acknowledgments of people that I've worked with in the past. This fellow here is Mr. Larry Ogren. He was my mentor. He was the one that started me on the path of the riddles of the Ridleys. Larry was Archie Carr's right-hand man when he was starting his studies in Tortuguero, Costa Rica. And then I became Larry's right-hand man when we started our studies of Ridleys in the Cedar Keys, which might make me Archie Carr's right pinky or something like that. But I owe it all to Mr. Larry. He was my mentor, and he got me to where I am today. And over the years, I've also had the pleasure of collaborating with a number of other people I've listed here. Jamie Barichevich with USGS, Greg Curry, who's with Rookery Bay National Estuarine Research Reserve, Dr. Tony Tucker, formerly with Moat, and a former supervisor, Wayne Witzel, with NOAA. Our research is supported in part by grants from the Sea Turtle License Plate Fund. Does anybody have a sea turtle license plate? Very good, thank you. A portion from the proceeds from each plate goes into a pot, and then each year there's a competition, a granting competition for those funds. And we've been pretty successful over the years. And then as Paul indicated, we also benefit from the memberships and the private donations to the Conservancy. So thank you.